Hey, hello everyone. Welcome to another session in this cloud data architecture series. Today we will be discussing about another comparison. This time it is between HDFS and S3. But like all the other sessions, this comparison would be mainly based on what is the use case, what are the workloads that you are trying to run, how this services fit into the scheme of things for a particular kind of a workload. And we'll try to discuss all these points mainly based on my practical experiences of working with these. We'll try to go through some of the advantages, disadvantages, but eventually it would be more of a comparison based on what I have seen so far in the data world. So let's get started. Um, and before we start, yeah, this session is more from an EMR centric perspective, like whether you should go for HDFS or you should go for S3 when you are trying to build a solution using EMR. Right, EMR is one of the most important data services within AWS. I often call it as the Swiss knife of AWS data services because of the wide variety of frameworks that it can offer, right from Spark, Hadoop, HBase, Hive, and you name it, and most of the things are there. So if at all you're using an EMR cluster, then you get a choice of either having your data stored onto HDFS or S3, and it's a choice that we need to make based on the use case and what we are trying to achieve. So let's start with HDFS first, right? HDFS is the Hadoop's distributed file system, right? It has been there since long time. And those who come from the Hadoop world, and if you have worked on the Clouderas and Hortonworks, you would be fairly aware of HDFS and its advantages. Since it's a distributed file system, it helps in parallel processing. It helps in processing the data parallelly when you have multiple data nodes, right? That was a typical Hadoop system where you had multiple data nodes which would come with its compute and its storage, and the storage would be HDFS. So what are the main advantages, right? Why we go for HDFS, right? And see, previously when cloud was not there, then all the big data systems were using Hadoop, and HDFS was the only choice. But with the increase in cloud architectures like AWS or Azure or even GCP, right? You get multiple other options. So how does HDFS fare against these? So it has still it has some of the advantages, right? The very first one, it's the data locality. When you have a data node, it comes with a compute power as well as the storage, which is the HDFS, and that is how the data locality is supported, right? So you are trying to process some data using the compute power on a data node, and the data is stored within that same node itself, right? So that data locality is there. Because of that, this results in faster processing because it's local data. You don't have to spend a lot of time or resources in the IO part of processing this data. So since because of the data locality, this results in faster processing and better performance. So this, when it comes to performance, right, this would be always slightly better as compared to S3, because S3 is it's not a local data which is present on your compute nodes, right? When it comes to EMR, you will spin up some instances and then you will have S3 as your storage. In these cases, it won't be a local data. But if you are using HDFS, this HDFS data would be still hosted on those EC2 machines which you are using as the data nodes or the worker nodes within your EMR cluster. Okay, so that is one of the most important benefit and one of the key criterias or key considerations when you are trying to use HDFS or S3 within an EMR cluster. Now, while we say this is a main advantage, right? The problem here is uh, there is always a chance of losing the data, right? So since this data resides on the cluster, right? See, HDFS would be on top of your EC2 instances, right? So there is always a chance that if you have your HDFS on your instances, right, the moment the cluster gets terminated or suppose it gets failed due to some issues, you will lose the data. So that's the main disadvantage, that you cannot have a persistent data with HDFS, right? That's the main issue. The second is, you also need a 3x kind of a replication, which is a mandatory thing with HDFS, right? At least a 3x replication. Now this results in having a more storage capacity. You need to provision for more storage capacity because you are going to replicate the same data, right? So if you're writing a certain data into HDFS and you have a 3x replication, it's going to take the capacity of 3 times of that storage, which will eventually increase the storage cost also. So with HDFS, you have to have a 3x replication, which increases the storage as well as the storage cost. The other disadvantage is all the admins, right? From the Hadoop admins would be well aware of this. You need to put in a lot of efforts in the data backup, right? Data backup, taking the snapshots, and if something goes wrong, to restore that data. So all these things needs to be done manually. Now suppose, see, in the previous Hadoop world, right, if you're using like Cloudera, it had its Cloudera manager. There was specific things like Cloudera BDR where you could replicate the data and all, right? So all these tools were there. Now if you're using this on EMR, right, you will have to do some of these things manually. You will have to maybe back up some of the data. You will have to move it to S3 eventually, right? A lot of things you'll have to do to ensure that the data, whichever is there in HDFS, you are preserving that. It should not go away once the cluster is down. So you'll have to manually do the things. At the same time, you will have to put in additional efforts for housekeeping of this data, archiving of this data. See, these all are like custom things that you will have to do because you are using HDFS. There is no inbuilt functionality, that there is nothing like an auto lifecycle management of HDFS data where the data will be moved after a certain amount of time. So you'll have to spend a lot of efforts on that. The same applies for data protection also, right? If you want to do some data encryption, data at rest encryption, then you will have to use the open source encryption mechanisms which are available with HDFS. There is nothing which comes with inbuilt, and all these features, right? I'm talking with respect to S3, right? HDFS was there. It has been there for a long time. It has helped a lot of workloads. But when you try to compare with S3, right, then you will see all this as some of the disadvantages, and how S3 is different. We'll look at it when we discuss about S3. But yeah, the bottom line is, uh, when HDFS, if you're using that, you will have to spend a lot of manual efforts. That's the key thing, right? That is the most important thing. Yes, storage cost is there, replication is there, but a lot of manual efforts are required. Even all these things gets added to the cost. So it's not just the service cost or the product cost or the storage cost. It's also the manual efforts, right? The actual person who is going to work on it. Do consider all those efforts as well. You need to consider those when you're comparing, when you're trying to do a cost comparison. And finally, right, any of these data lakes, they do not offer ACID kind of a functionality, right? You cannot update something. Now if you have a use case like this in HDFS, it's very difficult to implement. Again, people who have worked on it, they would understand, right? You can read the data from HDFS, you can create a Hive table on top of it, but you cannot do an update, right? That is where you have to bring in a lot of custom coding to do that, or you'll have to use Hive with ACID, which is again itself, it's a a different kind of a solution. But if at all you still need that, you might have to go with something like Apache Hoodie, right? Apache Hoodie is one of those file formats which does support ACID and time travel. Time travel, what is time travel? Those who are not familiar with time travel is nothing but you have made certain updates in data, but you want to go back and query the previous data or the previous versions, right? Like maintaining the versions of the data. So some of these tools do support that. So if you need some kind of a flexibility there, you can think of using Apache Hoodie. But again, it's not an easy task to implement all these things. It needs a lot of efforts. I think in the recent releases, EMR has also started supporting Apache Iceberg, which is also an open table format, and it does have its own ACID and time table properties. So maybe you can check out those as well. But yeah, for all of these things, it needs a custom efforts that needs to be put in to build all these things. Now, if we talk about S3, right, in comparison to this, you'll see there are a lot of advantages, right? There are a lot of advantages of using S3 in your cluster as your storage, right? The number one is the elasticity, availability, durability that S3 offers, right? You cannot really compare HDFS and S3 on that front. It is S3 is like 11 nines are durable. Uh, you can be rest assured that you are not going to lose your data, right? Same is for availability. S3 is always available. You don't have to replicate the data, right? That is not required to be done manually. AWS will handle it on its own. So you don't really have to worry about the data replication. Yes, what you can do, if you really want, you can do a cross region replication. You can do a few things related to that so that the data gets replicated to some other region. That you can do. The most important of all these three is the elasticity. You don't have to worry about the cluster planning and all. If you are using EMR with the compute as your EC2 and S3 as a storage, S3 is elastic, right? You get infinite data to be stored. You don't have to worry about that. Whereas if you are using HDFS, you will have to make provision for that. You either use the EC2 storage or EBS volumes with HDFS on that. So a lot of things needs to go into that while doing the cluster planning and all. So you don't really have to worry about it. So this first point itself, it is a huge advantage as compared to HDFS. Then, as I said, there is no risk of data loss because it is highly durable. What S3 really brings to the table with EMR, right? You can have transient clusters, right? The EMR, those who are working on EMR, you can either have a persistent cluster or a transient cluster. So what is a transient cluster? Transient cluster is nothing but a cluster which you can spin up and you can terminate it once your job is done, right? These are transient clusters. Now, to have that kind of a mechanism, you need to have a storage which is persistent. You cannot have this with HDFS, right? So that is why S3 is preferred and it enables you to have transient clusters. So once the data is computed, processed, you can have the data on S3 and you can close the clusters, terminate the clusters, and then you can access the data from S3, right? And again, even to access the data from S3, you don't really need the cluster. You can use EMR for your heavy compute where you are doing some lot of analytics and all, lot of heavy ETL transformation. But if you're just doing a query, if you're just doing a simple querying, you can still use Athena, right? You can have your Athena tables created on top of S3 and you can access the data. So that's the beauty of this, right? You can have S3 as your storage for EMR. Let EMR do the job of loading your daily ETL jobs, nightly batches, all the heavy processing. Close the cluster, terminate the cluster once the job is done, and in the morning the business users can use Athena for interactive querying. Right, so that's one way to use that. In fact, you can also, if you already are using Redshift and you have Redshift Spectrum, even you can query the data from there. But yeah, it enables S3 enables you to have this transient cluster. It can help you saving a lot of dollars when it comes to transient cluster. Right, compare it against running a cluster 24/7 just to keep the data access. Right, just to have that mechanism to access the data. Right, if you are using HDFS, you terminate the cluster, you don't have access to the data. On similar lines, because here the compute and storage is separate, right? When you're using S3, see, this is an important concept and I always talk about this, right? Having your compute and storage separate. When you're using S3, you're having your storage as separate. So what happens is any risk related to the compute, right? Any failures related to compute does not impact your S3. So during any HA or any DR kind of a situation, right? Even if a region goes down, right? And if you have enabled a cross region replication, your data would get replicated to another region and you can spin up a cluster in that region, right? So that is how it helps. So you don't have to worry about data loss. It's just a compute which gets impacted and you can easily spin up a new cluster and start working from there. So having a separate compute and storage has its own advantages. So EMR with S3 gives you that flexibility, and it opens up a lot of use cases. You get a lot of advantages with that. um, then talking about encryption, right? We spoke about encryption for HDFS. You have to use some of the open source encryption technologies, but when it comes to S3, see, S3 is a managed service. It has within AWS a lot of things come along with S3, right? So you don't have to worry about all these things. It is inbuilt with that. Like, case in point is the encryption. If you are having your data on S3, you can have the inbuilt encryption mechanism of AWS. It can be a KMS based encryption, it can be an SSE, a direct AWS SSE encryption that can be used. Anything you want, it can be easily used, and it can be implemented within few seconds, and it has a very good integration, right? You don't have to worry about, okay, I've done the encryption, then how do I decrypt that, right? It is all there. You don't have to worry about having the KMS keys and managing them, rotating them. So all this comes out of the box. Same thing with the lifecycle policies also. When we spoke about housekeeping and archiving for HDFS, you have to custom build all those things. But when it comes to S3, all these things are inbuilt. You just have to go and configure these things. It can be the lifecycle policies, it can be the tiers of S3 that you want to use, right? And then after, let's say you want to archive the data from after 180 days to Glacier, or you want to go to deep archive, all those things are inbuilt. So it's just a matter of configuration, and you can create all your policies and templates for this and get it working. Versioning and access control, again, a feature of S3 which only is available within S3, and you cannot do that in HDFS. uh, Versioning is very important. If you made some changes to the data, but you want to again go back to the original one, you can still do that using versioning. You can have access control mechanism, can have your policies for S3. So all these things are when it comes to actual project implementations, right? Maybe on paper this all look very simple, but when it comes to the actual project implementation, right, um, building this, implementing this using custom coding and all, it's difficult. But if you have all these features already available with the really good integration with all other AWS services, it helps. And then S3 also has a good integration with the glue data catalog, with lake formation, so that access control and all can be managed. What's the only disadvantage, as compared to HDFS? The advantage for the HDFS was it could be more faster. On the same lines, S3 can be a bit slower as compared to HDFS, because there is no data locality. We are attaching it separately, right? So obviously it can be a bit slower as compared to HDFS. If you have some heavy processing in Spark and you are trying to continuously read and write into S3, the jobs are going to be slower as compared to HDFS, right? So what can be done, right? How do you overcome this? You have minimum IO operations, right? You don't really write everything into S3. If you're using Spark, it's all in memory. Only land the data that is really required. And then there are implementations, right, where you can use both. Okay, which is a better implementation. You have HDFS also and you have S3 also for all your temporary data, right, which is just required in the processing, and you need some faster sorting, faster IO. You put that data into HDFS, and the final data, right, all your final data that you need to persist, that is required for the cluster, that is required for the external users or the other users which are not into EMR, right, you have the data into S3. So have both in the scheme of things. So for faster temporary processing, use HDFS. For your persistent processing, persistent data, you land the data onto S3. That's one of the way to use that. And acid and all, uh, like, right, data lakes, acid is still not there, but with lake formation, recently there have been some updates. There is a concept called governed tables in lake formation. Using that, acid features and time table features are available. Maybe you can try that out. I think it's a GA now since November or December 2021. So maybe it might be worth checking that. But again, on S3, you can also have things like a Delta Lake, which is again one of the open data formats which can be used, and it supports ACID and time travel. So even that is possible. But yeah, I mean, the whole thing around ACID and time travel, these are bit difficult to implement on, maybe on HDFS or S3. you need to look at it, what is the best way of implementing that. But yeah, I mean, there are ways to implement it, and S3 supports that. So these are all the various advantages of S3. Now if you try to summarize all these things, right, and think about it, S3 gives you a lot of options, because the number one is, right, because of its availability, durability, and elasticity. That's number one. And second, the most important I think is because you have a separate compute and separate storage, right? This itself opens up a lot of use cases which you can think of. So that's the biggest advantage of having S3. So based on your use case and your workload, you can think about it. But most of the times, I think S3 would do the job for you. So yeah, you can definitely try out all these things, and then see what fits well for your particular use case, and accordingly take a call whether to go for HDFS or S3. But as I said earlier, it is good to have both of these in your overall scheme of things. But and most probably go for S3 for having a transient cluster and having the benefits of still accessing the data post the cluster is terminated. That's it for today's session. Thank you.